Hey, what's going on? This is another 3D design self-challenge video. So I know I recently did one, but it's been hard to find time to go ahead and finish building my quadcopter. But one of the next steps was to try to lay out all the electronics and then figure out where they go in the frame or where I want them to go. The next thing I was mounting was the receiver. And as you see, it has two antennas. It has antenna diversity, so, chooses the one that has the higher signal strength. So generally, you want those like 90 degrees out of phase, roughly. It can be, it doesn't have to be exactly, but somewhere in the neighborhood of 90 degrees. That way, regardless of which direction you bank, you should have at least one antenna that's somewhat generally aimed towards you, and not the tip, obviously, because signals come off the sides. So they have Hobby King. It's a cheap Chinese like RC parts site. It's over out of China, so it's slow shipping, but everything's super cheap. They have these, and you put these two little tubes in each side, and then you screw them together. And then I think it is a single screw hole in the bottom, and then but you would have to drill. For me to mount it centered, I'd have to drill a hole here. Usually when I see people use these, they'll mount them to the top plate. The problem is, the wires would come straight up and then split, and there'd only be a couple inches left, and that's obviously not ideal for antennas. You want them to be relatively straight from the point they come out of the receiver, and since I want the receiver mounted to the bottom plate, I decided not to use this. And plus, this is like a translucent. I was hoping it'd be more black. Obviously, when you 3D print something, you can print it to be whatever color you want, and I've been using black filament. So I decided what I want to do is, and actually we're missing a couple. I don't know if you remember from it, or if you even saw the prior video, but there's a standoff that goes there and there, and that's how the frame goes. So I was thinking of doing something kind of like the camera mount that I did in the last episode that, connects to these bars. That's what it'll hold it in place, and then it'll have some kind of things. So I guess before I explain that, I should explain what these are. These are just 3mm hollow plastic tubes. They're kind of bendy, but they're fairly rigid, which is good because, if your antenna's sticking out, I don't want the props. These motors are doing like 250 watts burst. It's a lot of power, a lot of downward air suction. I don't want it to suck an antenna into it. So it's good that these are really rigid. Now these feel a little bit more rigid, than these, but this should be sufficient. And it's not like the antennas are really long. So obviously the rigidity isn't as important close down. The longer you get, it starts to become a problem. So, I bought a pack of these for like $1 or something, like an 8-pack. I can just cut these down to whatever size I need, and it's just going to make something that mounts to these middle frame standoffs that has a little thing at the bottom that I can slide these into, and obviously holes at the bottom to where I can fish the antenna. Wires through. And then it'll hold them in place, and hopefully at a good enough angle that the blades won't eat them. So that's what I'm gonna go do, and I will be back with hopefully a finished product. Okay, so I came up with something. The video is really long, but I'll speed it up. Obviously, I guess you would have just seen it now after I edit this together, but yeah, this has a few problems. First problem, I can't get this to fit through. So, if you couldn't tell, actually, see, I don't know. Depends on how long the video is. I might cut some of the actual 3D designing parts out, and because I don't know if this will be the finished product yet or not. But obviously, this right here and this right here will go between the frame posts. So, does it fit? And I grabbed one of these and was test fitting it, and it's a little too tight. See how it snapped? I don't quite need it that tight. I mean, this is literally going to be sandwiched between the top and bottom plate, so it's not going to go anywhere. So really, it just needs to be not even snug. It just has to fit. And this is a little too tight for my liking. I don't want to crack the carbon fiber or put too much stress on it. So, yeah, jeez, the fact that it even snaps into there like that. For other applications, that might be perfect, but for this one, this isn't gonna work. And then these are too small diameter, and I could try drilling them out, but yeah, I'd rather just reprint it. These prints I've been using some pretty modest print quality settings, so it's been printing quickly, like in the order of 30 minutes. So I'm gonna go ahead and just print it again. But if you couldn't tell, the hole on this side is bigger than the hole on this end where you feed the wire into. But I tried feeding the receiver wire into there. It is very difficult because it's so low to the bottom and it's such a sharp curve, and the hole's so small. So I might just throw this, just scrap this, and then just start over. So yeah, if you didn't see the time lapse of me designing this one, that would be why. Because I think I'm gonna go ahead and redesign it. So I will be back in a second with hopefully a better version that actually fits. Okay, I'm back. And so I came up with a completely different design. Now, the first thing I was thinking about is, like I said in the last video, when you're flying these things forward, you have to tilt it quite a bit. The faster you want to go, the more you have to tilt it. So that means the antennas are actually going to start facing away from me. So if I'm tilted 30 degrees forward to get really fast forward flight, that means if the antennas are mounted straight up, they're going to be aiming away from me. And that is obviously going to create like a dead zone, which is going to be directly behind it, which in some cases will be where I will be standing with my transmitter. So that's not ideal. So I thought the first thing I was going to change, since I was going to redo it from scratch anyway, was to angle the antennas back. So this, especially since I'm completely a noob to 3D design, I don't know a lot about it. I'm self-taught. I watched some videos on YouTube and downloaded SketchUp and just started practicing. And I've had a little bit of success with some stuff, but I'm no expert. And so doing something that was angled on one axis and then twisting it to another angle on another axis was extremely difficult. And as you saw, despite how simple this design looks, this took a long time, if you couldn't tell. And you could probably tell that I did a lot of fiddling to get this to work and to clear the top plate and all that. Well, unfortunately, the design I think will work fine. So it'll mount where these two screw holes are here. And the props are loosely on here just for, I was just testing clearance with, where the antenna sticks out and such. But it would mount like such, and then these would come out at an angle like that. Unfortunately, these holes are too small for some reason, and I can't get these to fit in it. But as you can see, there's tons of clearance. Now in the back would be a better way to tell. So, I mean, there's like 3 to 4 inches gap between. You probably can't see, but you also have to trust me. There's a gap about like that between this prop and the antenna. The front one's a little closer, but it's angled away from it. So, as rigid as this is, there's no way it's going to be able to do a 90-degree bend to get to the propeller. So, as far as angle and placement, it's pretty much perfect, I think. Now, I didn't do it back super far. I think we'll see, because of the way I had to design it, because of my limited knowledge in 3D design. Instead of angling it one way and then angling it the other way, I had to angle it, along, say, the y-axis, and then rotate it along the z-axis. So I'm not exactly sure how many degrees that is, but you could probably kind of get an idea of it by looking at it. What is that? Maybe 20 degrees or something. It's enough that it should help. So let's see. Oh, maybe it's more than that. So this is angled maybe at 30 some degrees, and at this point the antennas, obviously I'm blocking my own shot, even angled this far forward, the antennas are still aimed pretty much straight up. So this should actually work fine as far as angle and clearance with the top plate. Now I know it clears the top plate because I designed the entire top plate in SketchUp for the last video, but in case you don't believe me, see, clears perfectly. But another thing too, not only can I not get this 3mm tube to fit in the hole, which again I could probably just drill it out, but I don't want to get my drill bit stuck in there, and I've had some minor injuries related to doing stuff with drill bits like that. So it'd be probably smarter and easier just to open it back in SketchUp, punch the hole out just like a 1/4 millimeter, 1/2 millimeter bigger, and then reprint it, and then just try it. If it doesn't work, not a big deal. It's only 25 cents worth of plastic I've wasted. So to save weight, I did a half tube instead of the full tube, just like I did with this, only this time I went with the outside. That way I have room on the inside to pass the antennas by, just for a little better clearance. But the top part fits very, very perfectly, actually. But the bottom, I don't know if it's because I'm not printing directly on the build platform and I'm using a raft. I probably should have printed directly on the platform, but the hole kind of collapsed on itself a little bit, so this isn't fitting. So since I need to reprint anyway to adjust for these, I'm going to go ahead and punch these out a little bit bigger enough to where I should be able to get it to clear just fine. And that might do it. Oh, there's one more thing I was going to change. So I went to test fit, how hard it would be to get this to feed through there, and while it's not impossible, I have to kind of bend it, like 30 some degrees to get it to clear through the hole. And the hole's pretty small in there, so I think I'm also going to open the back of this up a little more and maybe create an indent to where I'll have some better fitment. So yeah, and then that should get me a better finished product, hopefully, and then we'll do an actual test fit. So I'll be back. Okay, so I reprinted and then forgot I forgot I was going to put a little notch along here, but I did make the holes a little bit bigger. So this is still the same. The holes don't look that much bigger. So I might be able to drill that out a little better to get these to fit, but I think I'm just going to reprint it. I don't like I said, these are antennas. This has no weight to it. It's just going to be, like a 4-inch section of this on both sides, and that's all the weight there is. So it's not like this has to be super strong. Now, having this strong will possibly help the structural rigidity of the craft when it's flying. So, I mean, I don't mind it being a little beefier, but I'm probably just going to, instead of trying to drill this, I'll just reprint it. It's not a big deal. Plastic's cheap. So one more go, plus I forgot to indent this to try to make it easier to put it in there. Now I did push this forward a little bit, so it makes it a little, darn it. It's a problem with things that are round, they roll. So I opened this top up, so I should be able to get this in there, and it is quite a bit easier. See, I was able to feed that through, but these receivers, like I said, are expensive, and I don't want wear and tear from it, having to turn a sharp angle against these sharp edges to wear the insulation off the antenna. So I think I'm going to go ahead and still reprint this, open these bottom 2 holes just a tiny bit more. Oh, that's one thing I didn't test either. Got too caught up in that business. Well, now it fits, but there is absolutely no friction. So the top fits beautifully, though. So what I think I'll do, keep the front diameter the same, and then bevel it to a smaller diameter in the back. So that way it'll fit in, and then by the time it starts to get near the back, it'll start to wedge in tightly. And it doesn't have to be super tight, just enough to hold it in there. So that's what I'll probably do. And then that way I don't have to worry about getting it perfect, because it'll just be too tight on one end, too loose on the other, and then somewhere in the middle it'll squeeze into there and clamp itself. And then I will make the holes on the bottom a little bigger yet again, and then do a little indent here so that I have a little more clearance for pushing the antenna in without too much room. Or without too much abrasion during flight, I guess. So yeah, I will be back again. Okay, I'm back, and I've not tried it this time. Usually I try before I turn the camera on. Yeah, look at that, see? Well, this side's a little tighter. Well, this side, beautiful. This side is a little tighter for some weird reason, but there we go. Now it fits. So it does fit. So that's pretty good. I'm happy with that fit. Now this, so it fits in the end just like it did on the last piece. So once I get it to about that far in, it starts to meet resistance, which is good. So that means, yeah, it's only coming into about there, but that's fine. I mean, it's in there really good. That's not going to come out during flight. So the next question is, now that I got this little groove that I told you I was going to make, how easy is it to get the antenna in there? One thing I didn't mention is the receiver actually be on this side, so it's actually going to have to do a sharper than 90-degree turn to get in there, but oh well. Well, I could put the receiver in front. Well, I'll figure that all out once I decide where I want everything placed and oriented, because I guess I could do it in front, but there's not quite enough room because of the camera. As where if I do it, if I have the receiver this way, it can go underneath the flight controller and be just fine. And then I can have a really short cable going from the receiver up to here, and it's actually going to be serial data. You can do individual channels where you have, it's basically like PWM from each channel going into all 4 channel inputs, or 5 or 6 if you have an extra channel for changing flight modes and stuff like that, into the receiver. But then you have 5 wires. These modern receivers will do CPPM, or in my case I have Futaba, and Futaba does s.bus, which I'm guessing just stands for serial bus. And using serial communication, ooh, if I can get this out of there, you can communicate between the receiver and the flight controller with one single cable with 3 wires, power, ground, and signal. And then that keeps it really tidy. Now obviously there's still 4 motor controllers 4 brushless motor controllers, so there'll still be 4 wires coming into the flight controller from those, but so that'd be 4 plus 1, so that's 5 wires versus if you didn't use serial data from your receiver to your flight controller, then you would have 8 wires or more, maybe 5, maybe 9 or 10, depending on how many extra channels you use for changing flight modes or for doing GPS hold or for, you know, whatever extra functions you program into your system. But I think we should go ahead and do some kind of just a rough test fit though. So let's see if this were under here and this were there. And I have a whole bag of these, so if I cut this to the wrong length, it's not too big of a deal. And I think you should always make your antenna a hair longer than your tube a hair longer than your antenna. There we go. So now, should probably take, I don't know which side's flatter. That fits nicely. Yeah, this side looks a little crushed, so we'll use this side. Maybe I can smash it back into the right shape. There we go. Cool. So now, just need to feed. Guess I don't have to be under there to do this. Feed the antennas from the receiver carefully into the holes. This one's, oh, there we go. There we go. Oh yeah, once it starts going, it glides. So look at that. That's awesome. So this would then go. Crap! I put them in backwards. I forgot I was going to mount the receiver on the other side. Could be one of the most boring things you've watched online. I don't know. If so, I apologize. That's not my goal. I could cut a lot of this out, but it takes more time, and I do a lot fewer videos if that were the case. So I'm just kind of. See, I don't like that's binding like that, but. That's actually not terrible. Yeah, and don't suggest making these curved at the ends because that is way beyond my capabilities. So, well, like I said, rough test fit, so we'll just... Yeah. We'll move the BEC out of the way, and there you go. And it's, oh yeah, it's not bolted in, so I shouldn't twang it like that, but it's pretty damn rigid, and it's facing away from this prop, and then it has just miles of room from this one, especially because the props are angled for fast forward flights. So yeah, as far as getting the antennas going, I'm pretty happy with them. Yeah, I think this video has been long enough. Hopefully this is interesting to somebody out there. If not, my apologies. We'll see you in the next video. Bye.